Hello, today we're going to talk about naming functional groups. These are organic compounds that contain essentially oxygen and nitrogen atoms, and in some pattern that is given a specific name and also changes the way the end of the name works. So there's a suffix that's given for each type of functional group, and this table is at the end of my handout, and I'll talk a little bit about, we'll do most of these in this problem. I want to mention that there are generally two types of names. There's systematic names and common names, and in some cases you can do either one. In some cases where you can only do the systematic, essentially. So if we look at this first compound, you should be able to recognize the type of functional group, and that's what I would learn first. So this is an amine. We have basically a nitrogen group here, and we talked about before, this is known as an amine. So be able to recognize that. And then there's two ways to name amines. As I said, systematic and common. On this table, the systematic suffix column has the correct ending here. I just want to make a note that this here is actually a common name. So it doesn't have, in this example column, it doesn't have the systematic name. So just make a note of that. Also for ethers, they don't have a systematic suffix. We'll talk about an ether this problem in a few minutes. This also given here is the common name, so it doesn't have the systematic name. But we'll go over these in these examples, and I'll show you how that works. Systematic, that's what I mean. So first compound, we have this amine, and if we're doing, so again, this is going to be kind of systematic naming system. We follow the same rules as before. Find the longest carbon chain, number it, always give priority to the functional group. So the longest carbon chain is going to be this one here, right? And then we can number it from the left or from the right to the left, which is the correct way. So because the functional group gets priority, we have that getting the lowest number, which would be a 2. So I'm going to cross off these numbers. So we're going to have a 5-carbon chain, and so therefore we're going to have a pentane. But like before, we get rid of the kind of normal ending, like if it was a double bond, we'd call it ene. And for these functional groups, we get rid of just the e at the end, and then we put whatever the suffix is. So it's actually pentanamine. Pentanamine, I think most people say pentanamine. And we're going to put a 2 here to denote this is where the amine is, right, on the second carbon. Okay, so then everything else that's not essentially circled right now has to be named as a substituent. So we have a methyl. We also have an ethyl. Remember when we name them, the ethyl goes first, it's alphabetical. The one thing that's different though here is that you can have substituents off of the nitrogen, in which case there's no number for that. So what we use is just an N to denote coming off of the nitrogen. So we're going to say N-ethyl and then 4-methyl 2-pentanamine. So again, substituents in alphabetical order. if it's coming off of nitrogen, capital N dash that. Otherwise, if it's coming off of the parent or root chain, number it like normal. So that can be kind of weird at first, but I think, hopefully that makes sense and you can practice some of those. Okay, so we have here a functional group that's an oxygen in between two carbons. So this kind of COC kind of bridge is known as an ether. So again, you want to really, learn those, use flashcards or whatever you need to get those patterns kind of ingrained in your mind. So you start with that. So there's two ways, and depending on your professor, I know some of you have different professors, so this is kind of a general video. I would just go with, obviously, from your lecture videos and slides, what they want you to know. Some cases, you might just need to know the common way. Some cases, you might need to know both ways. Okay, so we'll do the systematic way first. And in this way, there's actually no suffix. If you look at the table, it shows you for an ether here, there's no systematic suffix. In this case, it's a little bit different because the oxygen group of the ether is named as a substituent. So we find the longest carbon chain, which will be 4, right, versus 2 on the other side. And then we're going to renumber it, so we want to get the lowest number for this functional group here. So we're going to have a butane, and then this oxygen group plus 2 carbons, that's called ethoxy. So the oxy coming from oxygen. So we have 2-ethoxy butane. So the systematic naming, essentially the oxygen of the ether group is named as a substituent off of the main chain. Common name sometimes is just easier. In this way, it's always going to be blank blank ether. There's like the example in the little chart. So we just name the 2 groups that are attached to the oxygen. So we have, in this case, we have an ethyl, and we have a 4-carbon group, which is actually a sec-butyl. So it's going to be sec-butyl ethyl ether. I can kind of draw this here. So for the common name, we're going to, let's say this will be red. Or let's use the colors up there. So this will be green. This is kind of like our root name from the first one. And then we have our O here. And we have our 2-carbon ethyl. So we're just naming, again, the 2 groups attached to the oxygen. Blank blank ether. Okay, here we have a halide and an iodine, which even though it's in that chart, they're not really considered pure functional groups because they don't ever like change the ending or get priority over carbons. This would be a true functional group, which we talked about before. It was an alcohol, right? A secondary alcohol. And that's going to have an OL ending. So this is the suffix from the table. That, again, gets priority. So when we number the ring, we can go either way, that way, or 1, 2, 3, 4, 5, 6. Okay, so definitely 1 for the OH. Now, again, we get to this tiebreaker with the iodine, which is called iodo as a substituent. And then here we have propyl, right? So we have iodo, propyl. Which one gets priority? Well, alphabetically, it's the I. So we're going to go with the counterclockwise numbering and then name it as normal. So 3 iodo, 5 propyl. And here's one thing that you can note is you don't actually need to put a 1 in front of the cyclohexanol. And in most cases, it's not included. So even though I guess if you put that, it would be correct, it's just implied because of the ring and the functional group that we know that that would be the one. So just 3 iodo 5 propyl cyclohexanol. All right, another nitrogen compound, which is again is an amine. And here we want to do the systematic. What's the longest chain? It's going to be 3 carbons. How are we going to number that? From the right or from the left? Well, from the left being 1, because that obviously has the lowest number for the amine group. What are the substituents? So if we just say 1 propanamine, again putting the amine ending here, that's just basically naming this, and then we have these 2 methyls that are not named, so we're going to name those, and because they're not off of the 3 carbon chain, they don't get numbers. Remember that we use N, so we do NN dimethyl 1-propanamine. So keep in mind that we do need the 1 here, because if we had a 3 carbon chain, the nitrogen could be coming off of the second one, right? And that would then be a 2-propanamine with the dimethyl part in front. But so again, rings usually with functional groups don't need the 1. Chains, straight chains, you do need the numbers because it's different depending on where they're connected. Oh, we need to do the common name. So common name we can do for this one, because the way the common name is essentially blank blank amine or blank 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 amine. Just it's kind of like with the ether where you have the carbon substituents that are attached to the nitrogen. So the nitrogen is assumed to kind of be like the parent, and then all the groups off of that are named. So we have 2 methyls and a propyl, and we just go in alphabetical order. So dimethyl first, and then propyl, and then amine. So kind of like think about with the ether, if you look at that one, how this is similar. Something something ether, something something amine. Okay, so hope that makes sense. Okay, there are 5 functional groups that have this pattern of a carbon double bonded to an oxygen. So when you have that, you really want to kind of see what it's next to, you know, on either side, and that determines the functional group. So essentially the last 5 in this chart, these all have that, which is called a carbonyl group. It's the name for the carbon double bonded to the O. So again, look at the things that are next to the carbon with the double bond O, and that's going to determine the functional group. And then the suffix again is given in the 3rd column. Okay, a lot of these don't need numbers, as you'll see, because they are always going to be on number 1. So keep that in mind. This being one of those types. And here, because we have an H next to the carbon with the double bond O, this is called an aldehyde. So again, flashcards or whatever you need to kind of memorize those patterns. Aldehyde has an ending of just Al. So the name of this is a simple one because there's no substituents, anything else going on. It's just carbon chain with this aldehyde. And we have 4. So we'd have butane. So instead of the E, we just drop that and becomes butanal. Okay, so and again, we don't need the 1, just butanal. It would have to look like this since the aldehyde is always going to be on the end. Okay. So here we have a carbon double bond and O. This is next to carbons, just carbons. So here we want to recognize this is a ketone. And the ending of this becomes ONE or own. So we'll have longest carbon chain, and remember that this is just drawn in a weird way to kind of throw you off, but this would be longest chain here. So if we number from the left, we'd have these numbers. Number from the right, we're going to get this. Which way is correct? So focus on the functional group, disregard any other substituents. The lowest number for that would be 3 versus 4 going this way. So the 3 correct way. And then we have 2 chloro substituents. So putting this together, 4, 5 dichloro, 3, and then instead of hexane, drop the E, add an one, hexanone. Ketones, we generally are going to have to number because they're essentially in the chain somewhere, but it would be different if it was like 2-hexanone, 3-hexanone. So that one is one that's number is important to include. And here we have a carbon double bond O next to an O and a carbon. So it's kind of this pattern, which is known as an ester. Similar to the next one that we're going to go over, and we'll talk about why in the next video. This is, again, OC instead of OH in the next one. So ester is going to have an O8 ending. Esters are somewhat complicated to name because there's 2 parts to the name. And this again comes from how they're made, which we'll go over later. So the first part is actually the group attached to the single bonded oxygen. So first part of name is attached to O, and that's going to be, in this case, isopropyl, if you recognize that 3 carbon, right? But branched off the middle one, so it's not propyl, it's isopropyl. There's a space, and then the rest of the molecule is the second part. So the second part includes the carbon double bonded to the O. Now, when we talk about how to make these, also this will make more sense because these esters are made from 2 different compounds, and one is an alcohol, which is where the first part comes from, The other is a carboxylic acid, which is where the second part comes from. So kind of that will be tied into that whole synthesis of an ester concept. So I think with the naming, this is kind of weird. Once you have learned how to make them, it just starts to kind of click. So the numbering of this should be straightforward. We know we're going to always, make that carbon there, number 1. So we're going to have just a 3-ethyl. There's a space between these parts, so isopropyl space, 3-ethyl, and then we have, instead of pentane, pentanoate. So that's the ester ending is O8. No 1 needed because it's always going to be 1. Okay. Lastly, carbon, double bond O, O, and then H, carboxylic acid. Should recognize this. This is what acetic acid is. Many common weak acids have the same functional group. Also written like this. So, Cu. That's Cu. So carboxylic acid ending is going to be oic acid. Should be pretty intuitive. And then that's always going to be the 1. So you have longest chain being this one here. And just have some substituents that we would normally name the same as if they were just on an octane chain. So we'd have ethyls, or 1 ethyl and 2 methyls, ethyl going first. 4 ethyl, 4, 6 dimethyl. And then instead of octane, drop the E, put oic acid. So there's your carboxylic acid ending suffix. And again, no 1 needed because it'll always be on the end, so it'll always be 1. Okay. So hopefully that makes sense. Again, focus on learning the functional groups first and then putting the names together. Let me know if you have any questions. Talk to you next time.